Hey everybody. So I'm just going to kind of go over the homework from yesterday. So some of these questions would have been done in a regular classroom setting where maybe you would have had to work a little bit more, like this one, for example, where I have this question: a pair of real numbers, x and y, are related by the equation below. So we have this equation, and you would have been asked, what does it look like? Or what do you think it would look like? And um, on a with a pencil and paper, you may try to use a table of values, or try to think about what it looks like. So what I generally would probably think of, if you look at this equation, like the x part is squared, the y part is squared, and if you remember from grade 10, the equation of a circle, you'd think, I think it's a circle, not sure. Now with Desmos, I can usually just click on it and boom, there you go, you see it, okay? So again, Desmos kind of helps us deal with graphing much more easily, okay? Which is to your benefit. So next screen, just it was kind of looking at the question in the previous screen said pairs of real numbers, okay? So here, if you think about how come the question is actually specifying a real number, it's a good question. So some of us may think that a real number is a number that is real. Seems pretty basic. But the next class will actually define what a real number is. And here, just to give you the short kind of version, why do you think in math we need to define a number? It's because in math we can have real numbers, have imaginary numbers. Oh, that sounds weird, right? Rational numbers, irrational numbers, etc. Okay, I won't get too messed up about that, but we will be in the next class talking about how different kind of sets of numbers. All right, here was just a little part to just kind of talk to you about how we can represent a relation. So we can represent it in words with an equation, input-output machine, which is what we talked about yesterday, set of ordered pairs, which is coordinates, a table of values, mapping notation, a graph, or function notation. All right. Here's just a definition of an ordered pair. It's a collection of distinct objects. Each element of the set is an ordered pair where the independent variable, the x, is written first in each ordered pair. So again, x is independent, y is dependent, or x is input, y is output. So here's just an example where I can have, here's a relation where my two things are the snack food in the vending machine and the cost of it. So if you look at this relation, the first value or the input is always the snack food. The output is the amount that it costs. So here in this table of values, we would just go back and refer to the numbers. So I have nachos are 3, Doritos are 3, Mars is 2, barbecue chips is 4, gum is 4, Pepsi is 2.5, 2.5, and Twizzlers are 3. All right. So again, just showing you that we can go from something written like this with coordinates or ordered pairs and write it as a table of values. All right. Then we talk about mapping diagrams, if you remember from the lesson. So mapping just describes how each value of the independent or the input is associated with the dependent or the output. Okay. So each input here is mapped to a specific output. And again, this, if you notice, this mapping diagram I actually just copied here. So this is an example of the mapping diagram written as a table. And this here is an example of the mapping diagram written as a graph. So notice here I have, when I look at it, I have 4 points, 4 inputs, right? So here I have 4 inputs. Or sorry, 4 ordered pairs that I see on the graph. So here's an example of what we did during the lesson, where I can have a mapping diagram that here shows a player and goals scored. So this is from 2019, not from 2020. So here I'm going to type Messi. I'm going to look where Messi, the arrow goes to goals. So he had 50 goals. It's not a bad season. Then Lewandowski, he had 54. Oh man, that is a pretty, it's a better season. Harry Kane has 36. Then we have Ronaldo, has 39. Sterling, that's 43. Mbappe has 44. And Aguero has 44. I think, right? Did I screw one of those up? No, Aguero has 35. All right. So we're going to have mapping diagram can be written as a table of values. Okay, so hopefully that's not too messed up. X column is the independent or the inputs. The Y column is the dependent, is the outputs. So obviously, once we have patterns that we notice in tables of values, we can use that to come up with equations, which are another powerful tool. So here we just want to type any linear equation you want. Doesn't matter. You can put whatever you want. Okay, you hit submit. Remember that each point on the graph is an ordered pair that satisfies the relation. So this line that you see here, if you think about it, how many ordered pairs are on this line? I'll let you think about that for a second. Technically, the number of ordered pairs on this line is infinite because the line goes on forever. So a linear equation has an infinite number of inputs and outputs. This one, sorry, I forgot. I meant to add to this screen, but I totally forgot. So you can just skip this one. It just says, hey, here's your equation from the last screen, which is fine. Okay. So now here we're getting into the input-output part of the function of a concept. So here, if we look, how many inputs do you see? Well, I see like one coming out of the, I don't know, what is that, like a barrel or like a minecart. So there's, one in the minecart and one falling into the top. See that like kind of diamond falling in there. Okay. How many outputs? Well, if you look, there's three areas where or let's just say there's 3. All right. And again, when you share your responses, you should see other people's responses here. So if you're unsure about stuff, then you may think about, oh, maybe my answer is incorrect. So you may want to go back and refresh. Here's another example where I have my function machine. Okay. So again, the first machine that we talked about was a little bit more complicated. And here, if we look, I have, what's my input? I have a number. So the input is 11. The output is 14. So what's the machine doing? Well, if you look, it's written there, but the machine is just adding 3 to each input. All right. So that means that whatever the input is, remember, X is the input, the function or the machine adds 3 to the input and then spits out an output. All right. So that's the key to understanding what we mean by a function, okay, in a mathematical sense. Mathematics It's about patterns. And when we establish a pattern, we can apply it to a lot of different inputs that give us outputs. And the inputs always follow the rule of the machine for every input that's put in. So here's just another example, right? If we look at a vending machine, we know that there are multiple inputs, so money, that can get us desired output snack, okay? And here we just have some characters, right, where I put in a toonie. My output is I choose a Dr. Pepper, okay? So if you put in a toonie, you can't pick a Dr. Pepper and a Coke. That's not allowed. So each valid input has exactly one output. So again, vending machines, I put in a quarter or put in a loonie or toonie, I can only select one item. And again, that helps us define the formal definition of a function. It's a relation where each input corresponds to exactly one output. Okay, for every input, there's only one output. And here, if we look for each situation to determine if the relation is a function, this one here, I have a set of ordered pairs. So what I want to do is I want to look and see, are there any inputs that are the same? So here, look, I have 8. That's an input. And 8 is an input. Okay, so I have an input of 8 that has 2 different outputs, 3 and 4. So this one is not a function. Okay. Now again, if you're unsure about that, if we go to Desmos for a second, again, you can always go to Desmos to help you graph or visualize this stuff. So -2 and 7, that's 1 point. 8 and 3, 8 and 3, 5, I think it's 5 and 7, and 8 and 4. All right. So if you look here, remember we talked about the vertical line test, right? If I draw a vertical line right here, the input of 8, which is right here and right here, the input 8 has 2 different outputs, which means that this one is not a function. Okay? So, oops, let me just. Here, our example with the soccer players and goals. This, if you think about it, this is an example of a function because each player corresponds to only one set of goals, right? So Messi scores 50. All right. You can't have an arrow for Messi going down here and then up here. So yes, this one is a function. If I look at this one, again, tables of values, do I have any repeating inputs? Well, I have 5 and 5, so those are repeating, but check it out. This input is the same as this input. So actually this one here is just the same point. So this one is a function. Now again, if this one, you're asked to explain your thinking. So you would have just kind of do the same thing where if I plot the points, you could have done it that way. So I have 5 and 7, 12 and -4, 0 and -4, 5 and 7, and -4 and 11. Right, so if you look, you only see 4 points because this point and this point, they're the same. So you don't see 5 different points. So yeah, this one, if you look at it easily, you notice that there's no failure of the vertical line test, right? Because if I look, like if I draw lines through the coordinates, they only go through the coordinates once. So yeah, that one's a function. Okay? And again, you can explain it given this example of a graph. You could have said, hey, I graphed this quickly on a sheet of paper and noticed that it passes the vertical line test. Or you could have just said, you notice from the coordinates in a table that these two are the same inputs, but they take you to the same output. So we're all cool. All right. This one we did yesterday. I took it up with everybody before the class was finished. So we wanted to show a table of values. So how we can do that, I'll show you. If I just make this x and then call this, f of x. I type in values -4, -3, -2, -2. The points are all showing up, right? You'll see these points on the graph. So that's how you can easily, as long as I define the function. So again, notice the way I wrote the equation, I didn't write it with y equals, I wrote it f of x equals. Okay. And then here, using function notation, get decimals to show you the y value when x equals, or x is -4. So here, all I got to do is, I'm using function notation, so I'm going to write f. And again, the input goes in the bracket. And then notice I don't have to write anything else because it calculates it for you right here at the bottom. So some of you, I remember someone asked, if I do this, what happens, right? Or is it giving me anything? You don't have to do that, right? Because it gives us the answer right here. And then down below here, we want to fill in the coordinate for the corresponding f of 3. So x is 3 and 12 is the point. I zoom out there, I'll see it right there. And we can label it. Okay? So again, it's just kind of going back and forth from using coordinates and using function notation. Here, type in the point corresponding to the notation. This one should be easy. So again, -6 is the input, or the x, and then the output is 1/2. So here, to get 1/2, if you just hit the backslash button, it turns it into a fraction, and then move it over, close my point, and there we go. All right. Type a sentence for f of 8 equals -3. So here we can say when the input is 8, the output is -3. Okay. Or you could say when the x value is 8, the y value is -3. Or you could write when the x value is 8, f of x is -3. Okay, because f of x and y are now the same thing. And then here was also one that we took up. What is the value of g of 6? So again, here, this is my g of x column. And I look, well, where's my g of 6? Well, so here, I don't want to look at this column, because if you think about it, if you see a 6 here, you may be thinking that, oh man, I'm going to look at this value, because some people were picking -2. Okay, but here, remember this 6 right there, that's the input. Okay, so when x is 6, what is the output? That's what this means, right? So g of 6 equals 3. All right, and you could have just written like that, and that is the end. All right, so hopefully everything is cool, no issues, and we will talk to you later.